everyone, welcome back. In this particular video, we will be discussing the problem reverse the bits of a given integer. Reverse the bits of a given 32-bit unsigned integer. Number of bits in the integer will be 32. Although you might be given a 64-bit integer as a parameter, but you have to consider only 32 bits from the right hand side, the last 32 bits. That is from 0th index till 31st index bit. And the number which will be given to you will be unsigned integer. It means the number will be positive integer. You will not be given a negative integer. And you don't need to figure out, or you don't need to basically worry about the overflow, because you only have to figure out the reversing of 32 bits out of 64. Input will be a 64-bit number. So there will be no such scenario where overflow is occurring. So let's actually do what? Let's actually take a number which they are giving you is a very long string. Although just doing the dry run or just thinking the problem in terms of 32 bits will be very difficult. Let's do what? Let's just for now focus on a number which is of 8 bits. I am taking a number which is 0, 1, 1, 0, 1, 1, 0, 0. How many bits are there? 1, 2, 3, 4, 5, 6, 7, 8 bits are there. After reversing 8 bits, obviously there will be zeros in the left. You can append as many zeros in the left. Same as a number is 932, you can append as many zeros, it will remain same in integer. Same thing for bits, you can append as many 0 bits in the left. But after reversing it, what will happen? Obviously these bits will go at the 31st index, 30th index and so on. But I am just showing you in 8 bits. So in 8 bits representation, this bit will go at the 7th index. This is 0th index, first index. Always bits are numbered from the rightmost bit. Second index, third index, fourth index, fifth index, sixth index, seventh index. So what will happen is the 0th index bit will go at the 7th index. The first index bit will go at the 6th index. Second index bit will go at the 5th index. The third index bit will go at the 4th index. The fourth index bit will go at the 3rd index. Then 5th index will go at the 2nd index. Then 6th index will go at the 1st index. And finally 0th index will go at the 7th index will go at the 0th index. So this is what the output will be looking like after swapping. So output will obviously be of the same number of bits. If input is 32 bits, output will also be 32 bits. If input is 8 bits, output will also be 8 bits. But the point is how to reverse the order of bits. See, when we used to reverse an array, when we used to reverse a string, what logic we used to apply? We usually tried to implement it using two-pointer technique. So here also what we can do is we can apply two-pointer, and using that two-pointer we will be able to reverse. But in array or in string, we used to apply two pointers on the indices of the array or indices of the characters. Let's say there was an array 10, 20, 30, 40. So what we will do? We will apply a left pointer on 0th index, a right pointer at the last index, n minus 1th index. Swap left with right. This will become 40. This will become 10. Left plus plus, right minus minus. Swap the left element with the right element. This will become 30. This will become 40. Left plus plus, right minus minus. As soon as left is more than right, we should stop. That is entire array is reversed. This was in array. Same for string also. Same logic we will apply for the numbers, but a single number. Bits needs to be reversed. So two pointer will be on bits. One pointer on the 0th bit. Let's say this is the pointer number 1. You can't say left or right because actually this will be right. Or even if you want to say this is right bit, the rightmost bit, the 0th bit. And this will be the leftmost bit, which is 7 in our example, although it will be 31 in actual, because the number is given as 32-bit integer. So last bit will be 31, starting from 0 till 31, 32 bits are there. But for now, let's just take 7th bit. Initially, what we can assume is output is empty. Empty means all the bits are 0. None of the bits are set. So if none of the bits are set, all the bits are 0. So initialize the answer, the output, which we need to return as 0. Start with the number. First of all, we are having the left bit 0, the right bit also 0. So if left is also 0, right is also 0, no need to do anything in the output. They are already zeros. So if left is 0, output at the right will remain 0. If right is 0 in input, output at right will remain 0. Let me just remove this thing, this arrow, which we are using for reverse. I know you already know that we have to reverse now. I think problem statement is at least clear. We are discussing second milestone, which is the problem approach. So we have to reverse it. What we are saying initially is, in order to reverse the 0th bit with the 7th bit, no need to do anything because both the bits are already 0. So they will remain 0. Left will become actually minus minus. That's what I was, instead of using left and right, maybe what you can do is you can use some other variable names for these two pointers. Left will become minus minus, that is from 7 to 6. Right will become plus plus from 0 to 1. Again, compare the bits. The 6th bit, that is a left bit, is a set, it is 1. So in the output also, but at the 6th index, no, in the output at the right index, I will make it set. Since that is not set in the output, I will let it remain not set. That is swapping the 6th index with the first index and first index with the 6th index. I will make this bit set in the output. I will let this bit remain same, that is 0 in the output. Make the left bit go to the right, make the right bit go to the left. Left will become minus minus, right will become plus plus. Now again, 1 and 1, both sides are 1. So left will make the right bit in the output become 1. Right will make the left bit in the output become 1. That is, 5th index will make the 2nd index become 1 in the output. 2nd index will become 5th index become 1 in the output. Left minus minus, right plus plus. This is 0. So in the output, the right bit will remain 0. Since right bit is 1 in the output, left bit will become 1. And as soon as you will do left plus plus and you will do right minus minus, left crosses right, we are able to reverse the entire bits, or you can say we are able to reverse the number in terms of bits. So this is the final output which we will return. Now in this logic, two important points which we discussed. One thing is, while we were checking whether the element, the bit at the right index or at the right left index, is it 0 or 1? So one function which we need to implement is check whether the bit is a set or not. Check set bit at a given index, in a given number at a given bit index. We need to check whether a bit is set or not. It will either give me true or it will give me false. And the other function is, if we need to set a bit in the output, we will call a function set bit, which will, in the n number, update the bit at the bit index to be true or to be 1 and return the new number after setting it. And the point, how will we implement these two functions, that you can maybe go through on your own, or that you may go through the previous questions regarding. We are just quickly going to revise these two functions, check set bit and set bit. So given a number, if let's say I have this number 0 1 0 1 0 0, and I need to check whether the bit present at the second index is a set or not. What we can do is we can create a mask such that all the other bits are 0, only the second bit is 1. And how will I create this mask? That mask can be created using one left shift B. If this B is 2, one left shift 2. Once the mask is created, how you can check whether that bit is set in the input number n or not? You can just do the n and mask. If you will do n and mask, what it will give you? 0 and 0 0, 1 and 0 0, 0 and 0 0, 1 and 1 will give you 1, then all the zeros. So if the output number after n and mask you are getting is non-zero, it means that bit was set. And if you will get a 0 value, it means that bit was not set. Maybe I can give you a quick example for that, where the bit is not set. Let's take the same number, but this time let's try to check for the third index bit. It is not set. I will create a mask where all the bits are unset except the third bit, which is going to be set. This is the mask. One left shift 3. One left shift 3 is the number. And now do the mask with n. You will get the number 0 and 0 0, 1 and 0 0, 0 and 1 0, 1 and 0 0, 0 0. So in the output, as you can see, all the numbers, all the bits will be 0. So it is equal to 0. It means that bit was not set. So here return true because number is not equal to 0. Here return false because the output n and mask is equal to 0. This is 2. Only check whether the bit is set. First function. But how to set a corresponding bit? If a bit is already set, then no need to worry. But how to set a bit which is unset right now? Maybe if I take the number, same number again, and if I try to set the third bit, how to set the third bit? Create the same mask, that is 0 0 1 0 0 0 1 left shift 3. Create the same thing, mask is same. But now to set it, instead of doing and, you have to do or operator. N or mask. If you will do or, all the other bits will remain same as in the input 0 1 1 0 0. Only the bit which you need to set, that will become 1. If it is not 1 already, it will become 1. If it is already 1, it will remain same. So this is how you will do the setting of a corresponding bit by doing or with mask. Checking was with and with mask. Setting is to or with mask. So now that you are good with all the approach and the concept also, we are good to go with the instruction manual. So what we will do is, we will maintain 2 pointers. We will say set left as the 0th index, actually right as the 0th index, because the 0th index will be the rightmost bit. So set right as 0 and left as the 31st bit. If the number of bits are 32, so it will be only till 31 because counting is starting from 0. Run the loop till the pointers are not crossing. So run a while loop only till what? Till right pointer, this pointer basically towards the right, it crosses left. You can say right if it becomes smaller than left, then stop, or left if it becomes greater than right, then stop. So we have to run the loop only till the left pointer is a smaller than right pointer, or even if it is equal, you can run the loop. It is your wish. You can write left less than equal to right, run the loop till that point, or less than equal to right. Both are correct. I am just using left less than right. Left less than right, what we will do is, we will check the bit at the left index if it is set or not. And first of all, we have to create the answer variable also. So set the answer as 0. Initially, it will have all the bits 0. And what we need to do is, now check the bit in n is a set. Check the left bit is a set in n or not. If it is set, if yes, then set the right bit in answer. If the left bit is set in input, set the right bit in output. And same for vice versa. That is, if check first of all, right bit in n is a set, then what we need to do? We need to basically say that if yes, then set the left bit. Left will become right, right will become left. That is what reversing is, 2-pointer technique. And once we are able to do it for all the bits one by one, we will also do left become minus minus, right become plus plus. That is, we will say that left is going from 0 1 2 3, right is going from 7 6 5 4 and so on. So actually the 2 pointers will not stop when left is greater than right. Right now they will continue. When left becomes smaller than right, then you have to stop, because left is coming from the right hand side, this left pointer. So I hope I am correct. Maybe what we are saying is, initially right was the 7th index, left was 0th index, left was, we are saying left is 31. Okay, no. If this is left, if we are saying left is 7 or 31, whatever. Swap left with right, left minus minus, right plus plus, 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 left minus minus, right plus plus. And if left becomes more than right, stop. If left becomes more than right, stop. That is run the loop till left smaller than right. Yes, everything is correct. I was confused a little bit. Anyways, this logic is correct. The only thing which you need to do is implement the functions checking whether a bit is set, setting a corresponding bit. So I will have a function to check a bit, which will return true or false. Check set bit, which will take the number and which will take the bit which you need to check. In that, what we need to do? First, create a mask. Create a mask as one left shift bit. First, make the bit 1 go towards that position which we need to check. And now to check, do the n and bit, n and mask. We will do the and operation. If n and mask, this value is giving you 0, then the bit is not set, then return false. Otherwise, if it is giving you non-zero, then the bit is set, so return true. This is how to check a bit is set or not. But we also have to implement the set bit function, which will set a bit. So setting bit will update the number and we will return the updated number, which will take the number which you need to set in and the bit which we need to set. So for that, again, create the same mask as in the previous check function. But this time, instead of doing n and mask, we will do n or mask and return the new number. That is, we will say return the n or mask, whatever the new number is, return that, so that we can update in the main function. So this is the entire instruction manual for the problem reverse the bits of a given integer. And what is the time complexity of this approach going to be? Since a number of value n can have log base to n number of bits, although in this question there are only 32 bits. So either you can say the time complexity will be n log base to n, where n is the number input number, or you can say, since question also says that only 32 bits are there, n can be at max 2 raised to power 31. So in that case, the time complexity can also be said like constant. So both are equivalent, log base to n or constant, because n is very small. Or even though n is large, log n will be very small, almost equivalent to constant. What about the space complexity? Space will not be extra as such, because we are just creating an answer variable, which is also a 32-bit integer or 64-bit integer, something like that. So constant space, constant time solution, or constant space logarithmic time solution, you can say any solution, any time complexity, both will be correct. We will be writing the code in Java programming language. So first we need to do what? We need to apply a 2-pointer technique on bits. So one pointer will be at 0th index, because the rightmost bit is 0th index. So right will be starting from 0 and left will be starting from the highest bit, the most significant bit, the rightmost bit, which is 31. And we will say answer is a long variable, because we have to return a 64-bit integer. Answer, although it will be initially empty, 0. What we need to do is, we need to apply the 2-pointer till left is smaller than or equal to right, or only smaller than right. Every time, check the left bit, check the right bit using the check bit function. We will apply the check set bit function in the number, check the left bit is set or not. If it is set, do something. Similarly for right, if it is set, we will do something. We don't need to swap directly, although we are saying that we in reversal logic we have to swap, but instead of swap, we are using the concept of check bit set bit. So if the left bit is set in the input number n, we will update the right bit in the output by making it set. So answer will get updated by setting the bit in the answer variable at the right index, not at the left index. And what about the right index if it is set in the input number n? Answer we will set at the left index. It is left set in input, right set in output. Right set in input, left set in output, vice versa. And after basically setting them, we also have to do what? We also have to basically do the left pointer plus plus, right pointer minus minus. Actually, left minus minus, right plus plus. It is a different kind of 2-pointer, where left is going from 0 towards the bigger value. Right is going from 31 towards the smaller value. Actually, I said actually inverse. Left is going from bigger value to smaller, 31 to 0. Right is going from 0 till bigger value. So right plus plus. Once the entire 2-pointer is done, we will return the answer. That is what we have to do. Although it was not written in the instruction manual, but that is self-explanatory that we have to return it. We have to print it or return it, whatever. The only thing remaining is how to check a bit and how to set a bit. So to check a bit or set a bit, first we have to create a mask. How to create a mask? We have to do the left shift on the number 1 bit number of times, whatever bit we need to check or set. So first create a mask as 1 left shift bit. However, since we need a long variable, we need to check in a long 64-bit integer. This 1 should also be in long. There are 2 ways. Either you can write long like this in front of it, or you can also write 1L. L means long. You are writing L to make the number digit 1 become long 1. Now check if the bit is set by doing n and mask, that we have already discussed in the approach. So if n and mask is going to give you 0, it means that bit is not set, return false. However, if it is going to give you 0, return true, it is set. So this is to check a bit. Similar way we will set a bit. The only thing is, instead of doing and, we will do or with n or mask. This n actually will not be the same n as the reverse bit function. It will be the answer, because we are passing answer here. So one small mistake found. You have to pass answer, not n, because we have to set the bit in answer. when we are checking in the input left bit is set, answers right bit will be set. If inputs left right bit is set, answers left bit will be set. So let's now run the code and see if it is going to work fine or not. Hopefully it should be, but let's see. It is going to take some time. So it is showing some error. We can't find the simple answer. It is due to some weird error. Actually, we have to call the set bit function. Why I am calling a function named as answer? I'm not sure why. Typo, big typo. But hopefully it should give me the correct answer now. Okay, no. So for a number 4326156, it is expected that it should give me this particular number. However, it is giving me 0. So it means in the output, none of the bits are getting set. This logic is not at all working. And why it is not working? The reason is a small error which we have done actually in the condition. Left, should it be smaller than right? No. Left till the point it is greater than right. So again, a point of confusion because left is starting from 31 or 7, the bigger index. Right is starting from smaller index. So instead of left smaller than right, we have to write the condition as left should be greater than right. Then only 2-pointer will run. How I am able to get the point that the 2-pointer is not running? Because answer is remaining 0. It means this loop is not running. So instead of less than symbol, we have to use greater than symbol here. Let's run it again and see. Again, it is taking some time. And as you can see, it is working fine now. Let's submit it and see if it is going to pass all the test cases. This is an older summation. It is right now doing the summation, the new one. So as soon as it is getting accepted for new one, it will show up. Let's wait for a few seconds. As you can see, now it is getting accepted for the new test case. Actually, the new code, the current code. So code is although very large due to the instruction manual and due to separate functions for check bit, set bit. Although there are inbuilt functions also available in Java to check a bit is set or not and set it also. But we are not using inbuilt ones because you should know the concept of masking. You should know the concept of checking, setting, unsetting, all of these. What is the time complexity of this code? It will be logarithmic of n, where n is the number which you need to reverse the bits of. Or you can say it is constant because number of bits given in the question are only 32. This loop will only run for 32 times. Both of these operations are constant operations or logarithmic operations, but still, since log n of log 32, you can say 2 ki power 32 will be only 32. It will be order of 32, which is almost constant. So a constant time, constant space solution. With that, we are done with the problem reverse bits of a given number. We will meet in a new video with a new problem.